First of all, let me introduce myself. I am Anup, and I work in LinkedIn as a site reliability engineer. And basically, I'm on the front-end side of things. So if there is any issues happening on the LinkedIn website as such, I am one of the people who would be coming into action. And we also take care of a front-end product which is developed from India. And it was intended for the developing markets. And that's where I am here to talk to you today for. So this is about like the ensuring high reliability of high performance applications. And the meaning of high performance application here is more like a front-end application which needs to respond as fast as it can so that it can serve its customer better. So today we'll be first finding out why we need this high performance application for the developing markets. So that starts with the status of internet in developing countries, and that's where how we derive like what needs to be the application. And then we just get an overview around how we built the application and how we set up the monitoring for it. And then we have a very crucial piece to the stock, and which is like the main reason I wanted to talk here, and I wanted to let everybody know about like the service workers, like its pros and cons. Not really cons, it's like if you just get covered on all those points, your service workers are really good. And then finally, I just conclude with the lessons, what we learned today. So let's start. Yeah, so India is one of the fastest developing nations, as everybody knows. And the 79% of internet is accessed through mobile in India. These are all from like websites. I've given the reference. Oh, it's not clear. Yeah, so these are public references, and out of which 85% are Android users. There are very less iOS users in India. And out of that, like whole of LinkedIn mobile traffic in India, 75% of our users use Google Chrome. So now this was the problem. So back in 2016, when LinkedIn had a major revamp in the front-end side, the mobile website was having the 90th percentile of around 24 seconds in India. And this was discovered during a user experience research in mid-2016. And that's when the country head, Akshay Kothari, he said, like, this is not going to work. And we need to make LinkedIn very fast in order to capture the Indian market. And thus, what it means is basically that, so if there is a decrease in around, this was an internal study which was conducted in LinkedIn, and it means that for every decrease in 100 milliseconds, we are around losing 1% of our ad revenue. And there are other reports from Amazon also, like they lose about 1.6 billion USD for 1 second delay in their website. This was a public report. And yeah, so with this thing in mind, how do we actually engineer a product which can serve very fast? And that's when the product came up with this number. So the page should load under 6 seconds. So how we came up with this 6 seconds is basically that we were looking at the average internet speed in India. That's about that's like 100 kbps in 2G networks. I mean, that's the average you get. Like you get 4G also, and you get terrible 2G also while you're traveling. So we took the worst case scenario, and that happens to be the 100 kbps. And to make the page load under 6 seconds, we just had around 100 KB, or the page weight has to be 75 KB in order to load it under 6 seconds. So this was the challenge. Now, to get the page load under 75 KB, what can we possibly do to have a very small page size? So LinkedIn, the flagship website uses Ember, and it's a client-side framework, or any client-side framework for that matter, is pretty heavy. The payload, the client-side framework, gzipped itself, can be a big size. There are exceptions, though, but mostly it's like above 75 KB. So there is no way that we can use client-side frameworks. And client-side frameworks are also, like, they require a computation on the client side. And most of the devices in developing markets like India are like, they have very mid-range or low-end Android devices, which means that the computation power available on the device is also less. So if we have a client-side framework, even if it's light, and if it does a lot of computation on the client, your paint can get slower. So this is why we decided to not go with any client-side framework. The second part is redirects. So if we have, what we noticed that was like any big website for now, like be it LinkedIn or Amazon, like, or you have always a lot of redirects. Because it's on a microservices architecture, you usually redirect from one service to another service. This means that for each redirect, we are losing about around 2 to 6 seconds in the redirection. So the only way to prevent this is to have no redirects at all. So this whole service will actually act like a very monolithic application, but it will fetch from all the, there is no redirects, and whatever is required for that page is given directly from the server. And next one is server-side rendering. So now that there is no client-side frameworks, it's pretty clear that we have to render it from server. So now I'm just telling about the server-side rendering advantages. So the best part is that you can control the payload size really well from the server side. And this means that you don't have to send out any client-side generating templates or anything. It's just the bare-bone HTML which is needed to show the page. And this is the best part about server-side rendering. So, and the main thing is that if you send just the required HTML, this means that, again, the client does not have to parse a lot of HTML. It just displays it directly on the browser, which means that is the way, like, the fastest paint we can achieve. Now let's see how it's actually built. So this is just a diagram where we have the first swim lane, which is the browser, and we always fetch the static contents from the CDNs. Then the request is actually, when the main request, which goes to our servers, we have the open source Apache traffic servers, which we use as our traffic tier. And we also have fuzzy servers, which actually get the request from the traffic layer. And fuzzy is actually responsible for filling in the templated content. So how it works in LinkedIn, this is actually covered in a blog post. So all the requests coming to the traffic tier are sent to a mid-tier first, in this mid-tier or the web front-end, which is the LinkedIn Lite service in this case. And LinkedIn Lite returns a template kind of file to fuzzy, and fuzzy actually fills in all the content and sends it back. So the advantage here is that you can fill in all the template like parallelly, and the response is given out faster. This whole process with the server, with LinkedIn Lite, it takes about 2 to 3 seconds, like whatever the page request is. So this is where we have a good advantage. What we have done with LinkedIn Lite web service is that we have kind of combined the front end and mid-tier together in a single thing, so that it actually has lesser number of hops to other services, and all the data is pre-filled and sent out in just one go. And we also have early flush enabled, which means that with HTTP early flush, the head part of the HTML is sent out first. And this means that you can, while the server is rendering the content for the page, the static assets are being downloaded in parallel because the head is already sent out, and the browser would have already processed the head. So this is, again, an added speed to the website. So now that we built out LinkedIn Lite service, it was at the end of 2016, we launched LinkedIn Lite, and right now it's completely ramped in India and around 66 countries, and we are ramping more. We are ramping also into like China, the other big markets. So in India, if you are using LinkedIn from your mobile browser, you will see that it just loads under 6 seconds. Or you should see something loading up in the 6 seconds, and then it's really fast, even in a very bad network. So now, after LinkedIn Lite was launched, we thought, how can we improve the mobile experience for users without actually adding more weight to the, it should be fast, and we should also give a good user experience. And a website is pretty limited to how we can give a really good experience. That's why we have mobile native apps. But at the same time, we cannot go for a fully blown native app because, again, it would increase the web size. So keeping size in constraint, that's when the team decided to build a native app for LinkedIn Lite. And this is a very lightweight app, which is less than 1 MB. And it's available in the Play Store for all the countries in which it has been ramped, which the major market is, again, India. And the main intent for the app was that we could give an app-like experience with a very small weight, and also the support for native features like notifications. So the most recent feature which we launched in LinkedIn Lite app was the support for notification channels in Android version 8. So if you have an Oreo phone, you can actually choose what kind of notifications you receive, which was not possible before. This is with the help of the new notification channel support. And how we built this app. So just to put in perspective, 1 MB for an Android app is pretty low. So even the Hello World app, if you try to build it using Android Studio, it comes out to around 2 to 2.5 MB. This is with the latest SDK. And 1 year back, it was even worse because it was keeping around 3.5 MB for the APK. So what we figured out was that Android by default ships a lot of themes along with the app, which is really good if you are having a native experience. But we decided to go with the web views. And in the case of web views, the whole rendering happens on a web view is kind of like a Chrome tab. So the whole rendering happens on that Chrome tab. So you really don't need all these themes. And that's why we decided to remove all the themes, which actually reduce the app size by quite a lot. And so it came down to 400-ish KB. And then we added a small monitoring layer, like a tracking layer on top of it, because we need to know whether we are doing things right. So, and the monitoring is not very extensive. It's just the basic monitoring, which we just like the app startup and times and all those things. And then the change in approach was basically you use this monitoring layer would only track the native functionality, and we have a monitoring layer for the website. And since we are using the web view, we can actually leverage that too. So it's kind of a hybrid system where you have the native monitoring as well as the web view based, the normal JavaScript or the other monitoring. And then we depend completely on the server side so that we don't ship out any unnecessary, or we don't add to the weight of the app. And again, if you have client side, it can slow down the device. So again, we completely depend on the server side. And then we have not added much features like animations or things into the app. It's mostly the functional features and only the necessary features like notifications, where we think that the user can get a lot more value. And this is how we built the Android app. Now, coming to monitoring the application. So like, this is quite interesting because in normal applications, you monitor the 4xx and 5xx usually. Usually, nobody monitors the 3xx bit of it because it's like we don't care really that much. But for us, with LinkedIn Lite, we had to make sure that we should not have any redirects. So we had monitoring on 3xx also. And we were using InGraphs, which is an internal tool in LinkedIn, through which we get the graph plots. And we were using that and the open source Iris tool, which is open source by LinkedIn. We were using a combination of these both to have alerts set up on the different pieces. So next thing was the client-side monitoring. So apart from the server-side monitoring, which would monitor the page load time and the server's response time, the 5xx, 3xx, 4xx, we also had the client-side monitoring. So how we monitored client-side was like with a service called CatchPoint, which was just for availability. And then we used the window.navigator object, or it is also called real user monitoring. And this was introduced, like it has been there for quite a while. And it can give you a whole split of the request. That is how much time it took for DNS to resolve, how much is your TTF, the time to first byte, and so on. So we use this object, and this is the primary essence of our client-side monitoring. And it tells us how long requests take and what's the different resolution times and how much time it takes to parse, based on which we act accordingly and reduce the time as best we can. So this was the main monitoring aspect of it. And here, the best part is that it's all server-side rendered. But at the same time, we cannot give a very good, slick experience if you have a server-side rendered app. That is, when you navigate from one page to another, for a small time, you see that page getting replaced, like a flickering effect, even no matter how much fast you make it. So this can only be done through client-side. But at the same time, like, we cannot use client-side frameworks because of the weight. Now, how do we achieve a better experience? And that's where the service workers come into picture. So let's see what service workers are. Service worker is just like a script which runs on your browser in the background, and it is done as it is like an intermediary in between your web page and the server. So this means that all the requests will be fired through the service worker after it's installed, and this also has it also opens a lot of features to the plate. Like, you can have notification support using service workers. You can have a different caching layer using service workers. And there are a lot of possibilities. And how did it benefit us is basically it helped us to develop a progressive web application. So by progressive web application, this is a concept brought in by Google, and where we have, it basically enables rich applications on your mobile and almost a native app-like experience. And you can have notifications, you can have support for offline mode, which is pretty cool. Like, even if your website goes offline, the user can use the website. Then you can even have a splash screen for your website and make it look exactly like an app. So when you open the website, you have a splash screen opening up, and then you have a full screen real estate to render your application. And you won't see the Chrome bar anymore. So to develop this, like how we added more value to users using service workers was we had, this is the intermediate layer of service workers on the second swim lane, if you see. And rest all is the same. So here, the only difference is that you have a service worker cache. And this is pretty amazing, because now whatever request you're firing, you can actually cache it. And you can give it to the user. And the cache is completely controlled by you. which means that we can choose when to use the cache and when to not. And this is how we actually arrived at the almost app-like experience and the fastest possible LinkedIn experience. So what we do here is that we cache the request of what the user is going to tap next. I mean, usually we cache all the, if you go to LinkedIn today, you have the basic pillar pages, and the pillar pages are cached when you load the site for the first time. This means that when you go switch the pillar, immediately you get the content there itself. It's like hardly 200 to 300 milliseconds. So this is really slick, and this has the best experience for the user. But now this is the main part of the talk where service workers are really powerful. And with great power comes great responsibility, like told by Spider-Man. So since service worker is an intermediary between your browser and the server, all the requests go through your service worker, which means that if you mess up your service worker code in any part, and if the service worker is rendered useless, then your client won't receive, or the user cannot see your website anymore. And in the worst case, you will see a connection reset, the Chrome dinosaur page, because if the service worker errors out. But otherwise, it will simply not load. And the typical cache timeout of service workers is 24 hours, and which means that if the service worker is errored out, the user has to wait around 24 hours to see anything. And there is no cache controller. You can set it, but in the normal setup, there is no way that the user is going to see the website again unless he clears his browsing data and unregisters the service worker. So how do we come across it? So how we at LinkedIn we did was, for every service worker, I mean, not every service, there is only one service worker for a website. So for service workers, you always have a kill switch. And this kill switch will basically tell whether this kill switch will be it will be dependent on a server-side response, and it will tell whether the service worker needs to be active or not. So for every request you do, service worker actually talks to that kill switch API or the call, and determines whether to show the service worker or not. So this means that even if you are if the service worker errors out, you can turn the switch off. Immediately, on the next reload, service worker will inquire if the service worker needs to be active or not, and the switch will say, OK, kill yourself, and the service worker will uninstall. And the second thing we did was we always set the cache control to private max age 0. This would increase your requests to the server side, but it's better to be safe than sorry. So this means that it will always try to do a head request and figure out if there is any change in the service worker. If there is a change in service worker, immediately it will try to update it. So you might ask, why do we need a kill switch and the cache control? I mean, both serve almost the same purpose, right? Yeah, it almost serves the same purpose, but service workers, by design, they don't update until you close all the tabs. So the kill switch would be the only way you can kill it instantly. So then the next part is like a good coding practice, where you have all your service worker related code after the lifecycle events of the service worker. So service worker has lifecycle events like install, update, and the activate. So these events, you don't actually, I'm not going into detail for service workers, but you basically have these events, and you don't want to have any error in that part. So you have that events, and you handle those events, and then you write all your code. So if you are using ES6, you can just import them after all the events are handled. This way, your service worker, the chance of service worker getting errored out is very less. So now I just have a demo of worst case scenario, what happens when your service workers error out. So this, I just recorded a video in case I'm not able to reproduce it. Yeah, so let's start. Here basically I'm trying to, is it clear? Are you guys able to see it at the back? No. So I'll demo it. Yeah. I'll end the presentation. So this code is actually written by Mike North. He's a Ember trainer, and he actually wrote a very good piece of code which actually like misbehaving service workers do. I'll share the link at the end. So how we are just trying to simulate how service workers error out. So I just have this sample app running, and so first time when you load the page, and this is where the service worker gets installed. So the way you see that is here. So it just says SWJS, and it's activated and it's running. So now this page will load. The base page will load, but let's say let's try to change some HTML content. So so let's say I'm trying to add a new content here. And if it was a normal page, it would have reloaded the new content. But when I click on this refresh, you see the request is not resolving. So this is like the nightmare. So you will see that no matter how many other times I try to reload, and even if I do a hard reload, it will install the same erroneous service worker. So that load will work, but the next normal reloads will all fail. Or basically, all requests to that particular domain would fail. So you never want this case. And the reason why this happens is because yeah, so basically what happens is like I'm just checking for whether the content type is HTML, and if it's HTML, then I'm supposed to return some content there. But I deliberately made it in such a way that it does not resolve ever, so it just keeps on an infinite loop. And this is a typical case. This would typically be happening if your service worker is errored out. And yeah, this is what would happen. The way to solve this would be like either you have so the commented part. So if you have that skip waiting, it would mean that no matter whenever there's a service worker change, it will just install. It won't wait for all the tabs to close, rather it will install immediately. So this is one of the tricks by which you can solve this particular problem. But if you like follow the basics, like have all the lifecycle events at the top and make sure your code the code at the bottom, this would never happen. Because I wrote it, I have made an error inside the lifecycle event called fetch. So coming back to presentation. This is keeping on playing on the video. Yeah. So coming back to the, this is the last part where I'm just trying to conclude what we told. And these are the basic lessons you have to keep in mind. So for a high performance application, when you want, we need to have all the basic monitoring covered, which here includes 3xx, and which is not typically monitored otherwise, but 3xx are a very big thing. And the second thing is that page load times are the key. So we needed the page load times to be under 6 seconds. So we had a server-side page load time limit, after which we think it's unsafe. If it goes above, say, 5 seconds from the servers, it's almost pretty much impossible that we can deliver it in 6 seconds on the client side. So we need to have those kind of levels. And also, we need to monitor the week-over-week increase. So the features come in, and it might be some feature which might slow down the entire app. So to catch this, the typical way is to have monitoring around week-over-week values, so that if you see a gradual increase, you would be able to catch it upfront, rather than being at the red line. And then service workers always should be implanted very carefully. So they always need to have the kill switch, and make sure your lifecycle events are separate from your code. So service workers otherwise are really, really awesome stuff, and we can have a lot of features on it. This is just the way, as SREs, we should be knowing about this, because when a front-end developer might miss out on some things, but we need to be able to catch these kind of errors. And the funny part is that there is no way you can actually, the request will not tell you that it failed. It's always in pending state. So there is no error or console error, nothing you get. So if you are in certain kind of situation, be sure to check the service worker. It might help you out. And then the last bit is the web views. So this is a pain when we developed the LinkedIn Lite native app using a web view. Web views work very differently in different versions of device. So if you're targeting below Android 4.4, I would recommend not to do it at all, because every Android version before that had a different version of web view, and every manufacturer also had some tweaks around it. So it's very difficult to find the compatibility. But above 4.4, the Android had introduced a concept called updatable web views, which actually depend on your Chrome version. So you just need to deal with the different Chrome versions. But still, they are pretty tricky to deal with. There have been there have been some cases where some styling did not work on a web view, but it was working fine on Chrome. So always make sure to test all your devices thoroughly before loading it, releasing it out to production, especially with web views. Otherwise, it might be not that big of an issue, but with the web views, they are. So I'm almost done with the slides, and any questions?